Okay, the second lesson that we're going to do, some of you already saw this lesson during class, so if you remember it, you can skip over it. But the second lesson is on what we call correlation. So we're going to go through a few examples. I already completed most of it, so you can kind of just get the idea. And then we'll do some practice questions. So in this first one that we're looking at here, number 1, we're looking at two variables, height and shoe size. We reorganize those variables, those values in height order from least to greatest, and this is our table. So if we're looking at the height, we can see we go from 65 to 67, 68, so that's increasing. And then if we do look at the shoe sizes, it's 8, 10, 10, 9, 11, 13, 13. So even though it does go down here, for the most part, the size of the shoe is actually increasing. So is there a relationship between a person's height and their shoe size? Well, the answer is yes. As height increases, so does shoe size. Does a person's height cause them to have a specific shoe size? Well, no. Two people of the same height can have two different shoe sizes. But the idea here is that, if you have a 4-year-old who's, 2 feet tall, 3 feet tall, I don't know how tall 4-year-olds are, but then if you have an adult, obviously the child's shoe size is going to be smaller. So if you were to show this graphically, if we have, that's going to be height. So if we have height and shoe size, as height increases, shoe size increases. And if we were to actually plot these points, you would find that they're scattered around that line. So would this relationship be described as positive, negative, or neither? Well, that's going to be positive. As one variable increases, the other also increases, and that's shown right here in this graph. Next, we have example number 2, and this is showing the relationship between a number of absences a student has and their grade in the class. So we reorganize this by the number of absences. So absences are increasing, 0, 3, 3, 5, 8, 12, so that's increasing. And again, if we look at the trend for their grade, we have 80, we do increase to 85, we increase to 90, and then we increase to 92. So it does look as though it's increasing, but then if you see, the more absences that you have, the lower your grade actually gets. Okay, so 3 absences, 5 absences is not significant over a whole term of a class. That's half the year if we're talking about us. But 8 to 12, that's pretty significant. So your grade does end up suffering. So the overall trend here, even though it's increasing a little bit, we would say that it is decreasing. Okay. So is there a relationship between the number of absences and a student's grade? Yes, as the number of absences increases, the grade decreases. Does the number of absences cause a student to have a specific grade? No. Students with the same number of absences can have different grades. As you can see right here, 2 students with 3 absences have a differing grade of 85 to 90. Would this relationship be described as positive, negative, or neither? That would be negative. As one variable increases, the other decreases. So again, if we show this on a graph, this would be our number of absences, and this would be our grade. And as the number of absences increases, the grade decreases. But as you know, certain absences, your grade could be up here, over here, some people lower. It all depends on your abilities and your efforts, as you know. But overall, that is a negative relationship. The next example we have is the 2 variables are number of hours watching TV and height, like your actual height of the person watching TV. And if we organize this by the number of hours watching TV, you can see that these numbers are all over the place. 66, 60. So we go down 6, up 10, down 20, up 8, down 4, up 18, I guess. So number of hours watching TV is increasing, but the height is just kind of doing its own thing. So it's neither increasing nor decreasing. It's everywhere. So is there a relationship between the number of hours watching TV and a person's height? No, the variable valuables are all over the place. If you think about yourselves as individuals, your height has nothing to do with you watching TV or anything like that. So you watching TV is not going to make you grow or shrink. It's not possible. Does the number of hours watching TV cause a person to be a specific height? No, they're unrelated. So therefore, is this relationship positive, negative, or neither? And that would be neither. So a graph of this would look like this. The number of hours would be down here. Height would be here. And you would have just a scatter plot that looks like this. It's all over the place. There's no general trend of increasing or decreasing. Okay. So what we're talking about and what I said in the beginning is what we call correlation, and that's a relationship or connection between two variables. We're going to describe these correlations as either weak or strong. It can be moderate, or there can be no correlation. We also want to take into consideration whether the relationship is positive or negative. So as you can see, what you're trying to look to do is get as close to a line as possible. The closer you are to a line with your scatter plots, the stronger the relationship. So if we look at this no correlation, it's not possible to create any form of a line. So if we wanted to circle all of these points in, it's a giant circle. There's no correlation there. But as you can see, if we bring these points a little bit closer together, we're creating more of an upward direction, even though it's still a very, very large oval there. And then as it gets stronger, you can see that the oval is getting skinnier. They're creating more of a line, these points, so that's a strong positive correlation. And then lastly, this is what we call a perfect positive correlation, because I can just draw one line through all of my points. Same thing goes for negative correlation. We begin with no correlation at all. So that's this here. That's a big circle. There's no correlation there. This weak negative correlation, they're getting closer together. You can see that it's going downwards, but not necessarily close together. And then they get stronger. We can close them in a little bit closer together. That's a strong negative correlation. And finally, we get to our perfect negative correlation, where our line can go through the points even though mine did not. Okay. So what we're going to do is we're going to talk about correlation coefficient, and that is a number between -1 and 1 that describes the strength of the relationship. So just like what we saw before, you're seeing we're seeing this correlation go from perfect positive to a high positive, a low positive, to none. And then we're just going to do that same thing in the opposite direction. Low negative, high negative, perfect negative. The numbers that go with it are they go from +1 to -1. So 0 is your no correlation, and 1 and -1 are your perfect correlations. The closer you are to 1 or -1, so such as 0.9 or -0.9, that's considered high or strong. And then as you get closer to no correlation, this would be considered moderate. And then we have also in this table, you can see the weak. So we consider weak correlations to be any of these numbers here, 0.1, 0.2, 0.3. They're very close to zero, but not necessarily zero. So it's showing a relationship, just not a strong one. Then we get to moderate, which would be about 0.4 to 0.6. And then lastly, we have our strong correlations, and those are the numbers close to 1 and -1, so 0.7, 0.8, 0.9. And obviously your last one would be no correlation, which is 0. So if we practice with these numbers, number 4, you see Bella recorded data and used her graphing calculator to find the equation of the line of best fit. She then used the correlation coefficient to determine the strength of the linear fit. Which correlation coefficient represents the strongest linear relationship? So keyword here being the strongest, and we know that's going to be close to 1 or -1. So 0.5 is not close, neither is -0.3. If we're looking at -0.8 and 0.9, 0.9 is closer to 1 than -0.8 is to -1. So our answer is 1. Number 5, the results of a linear regression are shown below. So in the next part of this, I'm going to show you how to find this correlation coefficient in your calculator. We are going to be looking at the value of R. So R is the correlation coefficient. And that's going to tell us the strength of the relationship. Okay, please keep in mind that it is not R squared, it is R, this one right here. Which phrase best describes the relationship between X and Y? Well, our R value is -0.896. So right off the bat, we know it's negative, so we can cross out choice 4 and choice 2. And then we have, it's pretty close to -1, so that's a strong correlation. So that's choice 1. A strong negative correlation. Number 6, analysis of data from a statistical study shows a linear relationship in the data with a correlation coefficient of negative. I know this negative is kind of hidden there, but R is equal to -0.524. Which statement best summarizes this result? -0.5 is pretty much right smack in the middle, so it's neither strong nor weak. That's what we call moderate, and it is negative, so it is choice 4. Okay. All right, so how do we get this correlation coefficient ourselves? I'm going to show you how to do that in the calculator now. As I said in the last video, everyone should have downloaded a calculator app on their phone if you don't own a graphing calculator yourself. So what you're going to have to do is you're definitely going to have to follow these steps here, otherwise you're not going to be able to find your correlation coefficient in your data. So what we're going to do is we're going to hit the second button and then 0. So if you follow the steps on the calculator, let's do that here. Okay, so second, 0, that's going to bring you to a catalog. Oh, mine's not bringing me to that. It's possible that mine is, this calculator, it's already set, so I'll have to figure that out after. So hopefully diagnostics are on. If not, I'll have to help you guys with that as it's coming about. Otherwise, we get the correlation coefficient the same way we get our linear regression equation, which was in the previous lesson. So we might as well just go right to a practice question to show you. A nutritionist collected information about different brands of beef hot dogs. She made a table showing the number of calories and the amount of sodium in each hot dog. So choice A says, or not choice A, question A says, write the correlation coefficient for the line of best fit. So that means we want to find R. So our goal is to get R is equal to something. And the way we're going to do that is by doing these steps here. We're going to hit stat edit, and then we'll go from there. Let me just do this. Okay, so let's go to the calculator. We're going to hit stat edit, and you can see I have values in the calculator from the last lesson actually, so just to clear those out. I'm just going to do this I uploaded a video on how to use your calculators. Right. Why is this happening? Oh, sorry guys. Well, I guess you have to hit delete on this one. Okay, I don't know what that's about. Okay. Alright. So L1 is going to be the calories. So we have 186, 181, 176, 149, 184, 190, 158, 139. And then we have our milligrams of sodium in the next column. 495, 477, 425, 322, 482, 587, 370, and 322. So then we're going to do the same thing we would do to get our linear regression equation. We go to Stat, scroll over to Calc, and linear regression. Hit enter a bunch of times and you can see here your values are exactly where you need them to be. So I guess this calculator just does it automatically. So we're looking at the R value. Our R value is 0.9422. So I'm going to write that down here. 0.9422. But the directions asked to round to the hundredth place, so that is 0.94. Okay. Explain what the correlation coefficient suggests in the context of this problem. Remember, if you're ever told in the context of the problem, you are expected to mention the variables in your explanation. We know that 0.94 is a positive number and it's close to 1, so that's a strong. So let's move this up. Okay, can't. This is a strong positive correlation between, and this is when you just list your variables, calories and milligrams of sodium. In a hot dog. So all they're telling you is that the higher the amount of calories, the more salt there's going to be in your hot dog. All right, number 8, last one, and then we're done. Erica, the manager at Stellar Beans, collected data on the daily high temperature and revenue from coffee sales. Data from 9 days this past fall are shown in the table below. So we're looking at the temperature and the amount of coffee she sold. State the linear regression function f of t that estimates the day's coffee sales with the high temperature of t. Round all values to the nearest integer. So remember from the last lesson, we're doing linear regression. This question is not asking about the correlation coefficient. You have to be careful that you answer the correct question. Let me get a picture of these. I'll put them in the calculator. Okay. Alright, so we're going to do the same thing. We're going to clear out our lists. So stat, edit. And we're going to clear these out by hitting delete. Okay. And we're going to put our temperature in L1. So we have 54, 50, 62, 67, 70, 58, 52, 46, 48. Your second column will be your coffee sales. So we have 2,900, 3,080, 2,500, 2,380, 2,200, 2,700, 3,000, 3,620, and 3,720. Okay, so same thing, stat, calc, choice 4, enter, and we have our values. Remember, we were told to round to the nearest integer, so our A value is negative 58, so let's write that down. A equals negative 58, and B is equal to 6,182. Okay. So our equation, remember, y equals A x plus b. Okay, so that's your linear regression equation. Now, what this means is that so we have the slope is negative 58. So that means that her sales are going to drop as temperature increases. So if you think about it, that makes sense, because when it is warmer out, people don't necessarily want a hot coffee. All right, so it's negative. B says to state the correlation coefficient to the nearest hundredth. We don't have to do anything. Our information's already there. So we're going to look at our R value to the hundredth place. That is going to be 0.94. Oops. Okay, so does R indicate a strong linear relationship between the variables? Yes, it does, because it is close to positive 1. Okay. All right, so that's that for this lesson.